100 billion suns is not a size you can picture. The mind tries anyway. It starts with our sun, the thing that turns morning into warmth and holds the planets in their long, obedient paths. Then it multiplies that star until the number stops feeling like matter and becomes a kind of pressure. 10 suns, 1 million, 4 million, the mass of the black hole at the centre of the Milky Way. Then keep going, past every familiar anchor, until you reach the mass that has been proposed for Phoenix A star, around 100 billion solar masses. At that point, the comparison no longer helps, it breaks, and what replaces it is stranger than a simple giant. It is a hidden centre so extreme that its reality is written less by what we can see and more by what the surrounding universe has been forced to do. Before we go deeper, stay with the scale rather than the headline. Subscribe if you want space stories where the numbers are only the entrance, because Phoenix A star becomes more unsettling once it stops being a number and starts becoming an environment. The first trap is imagining a black hole as a black planet. That picture is wrong in the most important way. A black hole is not a solid ball with a surface you could strike. It is a region where gravity has curved the possible paths of light so severely that, past a boundary called the event horizon, no signal can return to the outside universe. The boundary is real, but not like a wall. It is a limit in what the future can still contain. Outside it, matter can orbit, heat, shine, collide, fall inward, or be blasted away. Inside it, the outside universe stops being reachable. That distinction matters for Phoenix A star, because the title can be misunderstood too easily. Larger than a galaxy does not mean a visible black sphere wider than the Milky Way. Even if Phoenix A star truly has a mass near 100 billion suns, its event horizon would still be tiny compared with the full diameter of a large galaxy. Vast by black hole standards, yes. Enormous compared with the scale of our solar system, yes. But not a galaxy-sized disk of darkness swallowing stars from edge to edge. The deeper shock is not diameter, it is compression. A galaxy spreads its mass through stars, gas, dust, dark matter, and long rivers of orbiting light. A black hole gathers mass behind a boundary from which no light returns. If Phoenix A star really sits near that extreme estimate, then nature has placed something comparable to the mass of smaller galaxies into a condition with no ordinary surface and no direct message from within. That is more disturbing than a simple size comparison. It means the universe can hide galaxy-like weight in a place that cannot be seen by looking at the place itself. So we have to look around it. Phoenix A star is associated with Phoenix A, the central galaxy of the Phoenix cluster, one of the most extreme galaxy cluster environments known. This is already a clue that we are not dealing with an ordinary black hole in an ordinary setting. Galaxy clusters are not just collections of galaxies drifting near one another. They are huge gravitational systems, bound by dark matter, filled with galaxies, and threaded by thin gas heated to tens of millions of degrees. That gas is almost invisible to human eyes, but in X-rays it glows. It is the atmosphere of the cluster, and in Phoenix, that atmosphere carries evidence of disturbance. This is where the black hole begins to gain a body. Not a body of its own, a body made of consequences. At the centre of the cluster, the galaxy is active. Matter near the black hole can heat violently before it crosses the horizon. Some of that energy can escape outward, not from inside the black hole, but from the region just outside the final boundary. Jets and outflows can push into the surrounding gas. They can inflate cavities, disturb the hot atmosphere, and leave behind structures that remain long after the outburst itself has changed. The black hole stays hidden, but the gas records the impact. That is the first real turn in the story. Phoenix A star is not best understood as a dark object sitting alone. It is understood as an engine inside a larger system. Gas falls inward. The central engine releases energy. That energy moves back into the cluster core. The hot gas is pushed, lifted, stirred, or heated. Some cooling is delayed. Some gas still cools. Some of that colder material becomes fuel for new stars. In many galaxy clusters, This kind of black hole feedback helps explain why the largest central galaxies are not forming stars as rapidly as simple models once expected. Hot gas in a cluster core should, in principle, lose energy over time. If enough of it cooled and condensed, it could produce enormous amounts of new star formation. But many central cluster galaxies are quiet. Their black holes appear to act like regulators, sending energy into the gas and preventing too much of it from collapsing into stars. Phoenix is unsettling because that regulation is not clean. Its central galaxy is forming stars at an extraordinary rate for a cluster core. The black hole is active, the gas has been disturbed, and yet new stars are still being made in large numbers. That does not mean the black hole is gently creating stars, or that feedback has vanished. The system is more complicated than either phrase allows. The same activity that heats and disrupts gas may also lift material into regions where cooling can continue. Cavities carved in hot plasma may be surrounded by colder structures. What looks at first like suppression can also become rearrangement. This is why Phoenix A star is more interesting than a record claim. A record claim can be replaced. A number can be revised. The mass estimate around Phoenix A star is not a direct nearby measurement like watching stars whip around Sagittarius A star in the Milky Way. It comes from modelling and from the extreme properties of the central galaxy and its environment. It should be treated carefully. The honest word is not certainty. The honest word is candidate. Phoenix A star may be an ultramassive black hole near the 100 billion solar mass scale, but the measurement is difficult, and future work may sharpen or change the estimate. That caution does not weaken the story. It prevents the story from becoming cheap. Because even if the exact mass changes, Phoenix remains extraordinary. The cluster is still massive. The central galaxy is still unusual. The hot gas is still disturbed. The star formation is still remarkable. The black hole is still part of a feedback system that refuses a simple label. The famous number brings us to the door, but the system behind the door is what makes the subject last. And the system is built from things our bodies were never designed to perceive. Human eyes would miss the X-ray glow of the cluster gas. They would not see the full structure of the jets. They would not trace cold molecular reservoirs by sight alone. They would not separate old starlight from fresh star formation hidden by dust. Phoenix has to be assembled through instruments, X-ray observatories for the hot atmosphere, radio and millimeter telescopes for jets and colder gas, infrared eyes for dust-obscured material, optical telescopes for the visible galaxy light. No single view owns the truth. Each one removes a different blindness. That is fitting for a black hole like this. The deepest object in the story is unavailable to direct sight. The event horizon gives nothing back, but everything outside that boundary keeps speaking. Hot gas shows where energy has gone. Cavities show where the atmosphere has been pushed aside. Cold gas shows where material has escaped the hottest phase. Young stars show where gravity has found dense fuel. The cluster becomes a record of the central engine's presence. The black hole does not need to be seen to be unavoidable. That is the cleanest way to hold Phoenix A star in the mind, not as a picture, but as a requirement. If the central engine were removed from the story, too many things would lose their cause. The cavities in the hot gas would need another source of power. The disturbed cluster atmosphere would lose one of its strongest explanations. The feedback cycle would collapse into disconnected facts. The active center of Phoenix A would become a bright mystery without an engine. The black hole is not visible in the ordinary sense, but once the evidence is arranged, it becomes difficult to leave out. That is how some of the deepest objects in astronomy enter knowledge. Not by appearing plainly, but by becoming necessary. Phoenix A star is especially powerful because the necessity operates at several scales at once. Near the center, matter falling toward the black hole can release energy before crossing the horizon. Around the galaxy, jets and outflows can push into the surrounding medium. Across the cluster core, hot gas can be stirred and displaced. In colder regions, material can gather into reservoirs where stars may form. At the largest scale, The entire environment tells us that this is not an ordinary galaxy with an ordinary central mass. It is a crowded, high-pressure setting where cosmic growth has been driven to an edge. That edge matters. Most black holes we talk about are already extreme, but they do not all test the same ideas. A stellar black hole tests what remains after a massive star dies. Sagittarius A star tests the center of our own galaxy and gives us nearby orbital evidence. M87 star tests the power of a giant elliptical galaxy and gave us a horizon-scale shadow. Phoenix A star tests something different, the upper reach of central black hole growth inside a galaxy cluster, where the surrounding gas is still behaving in a rare, revealing way. That is why it should not be treated as just a heavier version of familiar black holes. A larger black hole is not only a black hole with a bigger number attached. It usually means a different environment, a different history, and different evidence. A black hole with millions of solar masses can be studied through the fast motion of nearby stars, if it is close enough. A black hole with billions of solar masses may power a quasar or anchor a massive galaxy. A candidate at tens or hundreds of billions of solar masses belongs to the densest histories of cosmic assembly, where giant galaxies grow through mergers and where cluster centers collect matter over billions of years. Phoenix A star sits in that last category. The central galaxy Phoenix A is not a quiet island in a sparse region. It lives at the heart of the Phoenix cluster, where gravity has gathered galaxies, dark matter, and hot plasma into one enormous bound system. Cluster centers are special places. Over cosmic time, galaxies can sink toward them, merge, and build enormous central galaxies. Gas can accumulate. Black holes can merge or feed. The center becomes both a graveyard of old structures and a construction site for new ones. That dual nature is important because Phoenix A is not only old. Many giant central galaxies are dominated by aging stars and low star formation. They look mature, red, and mostly finished. Phoenix A refuses that simple image. Its central region is still producing new stars at a rate that stands out sharply for a brightest cluster galaxy. That means cold, dense gas is present in large enough amounts to build stars. In a cluster core, where a powerful black hole is injecting energy, that is not what the simplest expectation would predict. So the story tightens. If hot gas in the cluster core cools too efficiently, it should flow inward and form many stars. If black hole feedback is strong enough, it should keep much of that gas from cooling. Phoenix shows both forces at once. There is feedback because the gas is disturbed and cavities mark the work of outflows. There is cooling because cold material and star formation are present. The result is not a failure of physics, it is physics caught in an unusually exposed state, before the balance has been flattened into quiet. This is the point where the title's scale becomes more useful. A black hole this massive, if the estimate is close, is not just a passenger inside the system. It carries enough central weight and enough potential engine power to be part of the cluster's thermal life. It can help shape whether gas remains hot, whether it cools, where it moves, and how the central galaxy continues changing. The black hole's influence is not measured only from the event horizon outward by a ruler. It is measured by consequences. Consequences are what give the title its real force. 100 billion suns sounds like a final statement, but in the script it should behave like a question. What would such a mass imply? How could it grow? What environment could host it? Why is the measurement difficult? What would the cluster look like if the central engine were active? Why are stars still forming? The number should open the system, not close it. The event horizon is one answer, but only the first. For a black hole near 100 billion solar masses, the event horizon would be immense compared with the scale of human experience. Light crossing inward would not return. A spacecraft, if it could somehow approach in the right conditions, might pass a boundary with no solid marker and no visible surface, yet the crossing would be final. That is the strange violence of very large black holes. The danger does not have to announce itself locally. the geometry of escape has already changed. But even that horizon is not the main evidence for Phoenix A star. We are not seeing the horizon, we are reading the cluster. The hot gas tells one part of the story. It fills the space between galaxies and glows in X-rays because it is heated to extreme temperatures. The cavities tell another part. They show where energy from the central engine has pushed the gas aside. Cold gas adds a third part. It proves that some material has moved far down from the hot phase into a state where star formation becomes possible. Young stars complete the chain by showing that cooling is not merely theoretical. It has produced visible consequences. This chain is tighter than a list because each link changes the meaning of the previous one. Hot gas alone would make Phoenix a massive cluster. Cavities in that gas make the central black hole active in the cluster's history. Cold gas near those structures means cooling has survived the feedback. Star formation means the survival of cooling has become new stellar mass. The possible ultramassive black hole means the central engine belongs to the most extreme end of galactic growth. The system is not a pile of facts. It is a sequence of pressures. That sequence is what prevents repetition. Every return to the black hole must arrive with a new function. First it is mass, then it is boundary, then it is engine, then it is regulator, then it is historical record, then it is measurement problem. If the narration repeats hidden darkness without changing the role, it weakens. If it returns to the black hole after showing what the gas has done, the return strengthens. Phoenix rewards that discipline. The viewer should feel the object becoming more specific, not merely larger. Early on, Phoenix A star is a shocking mass estimate. Then it becomes a black hole whose size must be understood carefully. Then it becomes a central engine inside a galaxy. Then it becomes a driver of feedback in a cluster core. Then it becomes a clue to how the most massive black holes grow. The story moves by changing the definition of the object. By the time we return to the phrase larger than a galaxy, it no longer means what it seemed to mean at the beginning. At first, the phrase sounds like a claim about size. A viewer hears larger than a galaxy and imagines width, a black shape spanning stars, a hole so enormous that an entire galaxy could fit inside it. That image is dramatic, but it is not the most useful truth. The real comparison is sharper when it becomes more precise. Phoenix. A star may not be wider than a galaxy, but if the upper mass estimate is close, it may carry more mass than many galaxies contain in stars. That is a different kind of largeness, and it is harder to dismiss because it does not depend on exaggerating the picture. A galaxy is spread out, a black hole is compressed. That single contrast does more work than any monster metaphor. A small galaxy can contain billions of stars distributed across thousands or tens of thousands of light years. A black hole candidate like Phoenix A star concentrates a possible galaxy-scale mass behind a boundary that gives no light back. The galaxy declares itself by shining. The black hole declares itself by making every nearby explanation incomplete without it. This is why mass feels more frightening than diameter here. Diameter can be imagined as a ruler problem. Mass becomes a reality problem. If enough matter is gathered into one central object, the surrounding system must respond. Stars move differently. Gas falls differently. Energy can be released more violently before matter disappears. The central galaxy's history starts to look like a record of accumulation. The cluster core becomes a place where hidden mass and visible gas keep changing each other. Phoenix A star should therefore not be treated as a black dot with a number attached. It is a pressure point in a larger gravitational story. The pressure began long before the light we see left the cluster. Over billions of years, structure formed in the universe because gravity amplified tiny early differences. Dark matter gathered into halos. Gas fell into those halos. Galaxies formed, collided, merged, and sank toward denser regions. In a massive cluster, the central galaxy can grow through repeated mergers and through the slow arrival of material toward the bottom of the gravitational well. Its central black hole can grow with it, fed by gas and by the mergers of black holes brought in by other galaxies. That does not make a 100 billion solar mass black hole easy to build. It only makes the environment plausible enough to take seriously. Growth has limits. Gas does not fall straight in. It orbits, heats, and can be pushed away by radiation and outflows. A bright feeding episode can regulate its own fuel supply. Mergers take time. Black holes can be kicked, starved, or left wandering after complicated interactions. The universe can build huge things, but it does not build them casually. A candidate like Phoenix A star suggests a long chain of conditions that had to cooperate across cosmic time. That chain gives the mass estimate emotional weight. The number is not merely a present tense fact. It is a fossil of everything that may have fed the centre: ancient gas, merged galaxies, older black holes, cluster growth, and long stretches of time in which gravity kept drawing material inward. If Phoenix A star is anywhere near its famous estimate, it is not just large, it is old in its making. It is an accumulated history hidden behind an event horizon. The central galaxy around it makes that history visible in a partial way. Phoenix A is the brightest, dominant galaxy in its cluster core, the kind of place where cosmic assembly leaves thick traces. But unlike many giant central galaxies that appear mostly quiet, Phoenix A is associated with intense star formation. That star formation matters because it means the centre has access to cold gas. Cold gas is not guaranteed in a massive cluster core dominated by hot plasma and black hole feedback. It has to survive, condense, and gather densely enough for gravity to build stars. So the story narrows again. A huge black hole needs fuel to grow. A central galaxy needs cold gas to form stars. A cluster core contains hot gas that can cool, but black hole feedback often prevents too much cooling. In Phoenix, these three ideas collide. The black hole is active, the gas is disturbed, the central galaxy is forming stars. The system is not a static monument to mass. It is a live argument between heating and cooling. That argument is the strongest way to keep the narration moving. Heating alone would make Phoenix a familiar feedback story. Cooling alone would make it a starburst story. Mass alone would make it a ranking story. But all three together create tension. The possible ultramassive black hole gives the centre extraordinary weight. The feedback shows energy moving outward. The star formation shows that cooling has not been fully stopped. Each fact complicates the last. The cluster core becomes a test of how well black holes control their surroundings. In many massive systems, central black holes are invoked to solve the cooling flow problem. Hot gas should radiate energy and cool. If too much gas cooled, central galaxies would form stars at rates much higher than we usually observe. Feedback from active black holes helps keep that from happening. Jets inflate bubbles, energy spreads through the gas, cooling is reduced. The galaxy remains mostly quiet. Phoenix is valuable because it appears to catch that control under strain. The cavities indicate feedback. The cold gas indicates cooling. The stars indicate collapse into new stellar material. The three facts cannot be flattened into one simple phrase. They show a regulator that is working, but not completely, or a regulator that works unevenly, or a system caught during a phase when cooling has surged beyond the usual balance. The exact interpretation can be refined, but the tension is real enough to make Phoenix stand apart. This is where the black hole's influence becomes larger than the black hole. A horizon is a boundary. Feedback is a reach. The event horizon defines what cannot return. The jets and outflows define what can still travel outward. In Phoenix, the outward part is where the cluster story lives. Matter near the black hole releases energy before it is lost. That energy is carried into the surrounding gas. The gas changes temperature, density, motion, and location. Over time, those changes affect where the stars form. No single particle needs to travel from the horizon to every star-forming region for the black hole to matter. Influence is not a rope pulled across space. It is a chain of physical consequences. Central accretion powers outflows. Outflows disturb gas. Disturbed gas changes its cooling path. Cooling gas changes the star formation history. the black hole enters the story through each link. That is why the narration should not keep returning to darkness as a mood. Darkness is only the beginning. The more specific word is consequence. Phoenix A star is consequential because it helps connect the smallest meaningful boundary in the cluster core to some of the largest visible structures in that same core. It connects a hidden event horizon to X-ray cavities. It connects accretion to feedback. It connects feedback to cooling. It connects cooling to star formation. It connects one possible ultramassive object to the behavior of a whole environment. By this point, the title has changed shape. The promise is no longer that the black hole is simply bigger than expected. The promise is that the black hole forces us to rethink what big means. Big can mean mass. Big can mean reach. Big can mean historical accumulation. Big can mean explanatory necessity. Phoenix A star may be biggest in the sense that matters most for this story, not as a visible object, but as the hidden fact without which the surrounding system makes less sense. That kind of size is harder to visualize, but easier to prove. A diameter can fool the imagination. A mass can force the equations. If stars move too fast, if gas requires too much energy to explain its shape, if the central galaxy is too extreme to fit ordinary expectations, the unseen mass has to be accounted for. Astronomy is full of this discipline. It does not ask the universe to be visible first. It asks what must be true for the visible evidence to behave as it does. Phoenix A star stands inside that discipline, not outside it. The challenge is distance. Phoenix is so far away that we cannot weigh its central black hole the way we weigh the one in the Milky Way. Around Sagittarius A star, astronomers can follow individual stars as they race through tight orbits. Those stars act like test particles, tracing the gravity of the central mass with astonishing clarity. Phoenix A star does not offer that kind of intimacy. The region where its gravity dominates is much too small on the sky, and the cluster is much too distant for that simple, direct method. So the famous mass becomes an inference. That word should not feel weak. Much of science is inference. The question is not whether an estimate is inferred, but how strongly the evidence supports it, and how honestly the uncertainty is held. For Phoenix A star, the 100 billion solar mass figure belongs to the extreme end of model-based estimates. It is serious enough to discuss, but not clean enough to treat as a final courtroom verdict. The most responsible version of the story lets the number create awe, without pretending the measurement is finished. That balance is rare in popular black hole stories, and it matters. Too much caution kills momentum. Too much certainty kills trust. Phoenix needs both motion and restraint. The viewer should feel the pull of the extreme estimate, then understand why the exact number is difficult. This does not reduce the scale. It makes the scale more real, because real science almost never arrives as a perfect slogan. It arrives as evidence, model, limitation, revision, and convergence. The limitation itself points back to the size of the system. Phoenix is not a nearby laboratory. It is a cluster whose light has been travelling for billions of years. When its signal arrives, it has been stretched by cosmic expansion and thinned by distance. The cluster core may be rich in information, but every piece has to be extracted carefully. X-rays from hot gas, radio emission from jets, infrared signatures of cooler material, optical light from stars and galaxies. Each stream has its own bias, its own blind spot, its own part of the truth. That is why Phoenix is assembled, rather than simply seen. A visual image might show a bright central galaxy and surrounding structures, but the important story is layered below normal sight. X-rays reveal the hot atmosphere. Radio and millimeter observations trace outflows and cold gas. Infrared data can uncover material hidden by dust and phases of gas between hot plasma and star-forming clouds. The system becomes sharper when these views are combined, but combining them is not decoration. It is necessity. Without the layers, Phoenix becomes a blur with a headline attached. With the layers, the headline becomes physical. The hot gas is not background. It is the medium through which feedback becomes visible. In a massive cluster, This gas fills the space between galaxies. It is thin enough that a human body could never feel it as air, yet spread over such a vast region that it contains enormous mass. Its temperature is so high that it shines in X-rays. That glow makes the cluster's atmosphere readable, like a map of pressure and disturbance. The cavities in that gas are among the most important marks. They are not holes in space. They are regions where the hot, X-ray emitting gas has been pushed aside by activity from the central engine. Their existence means energy has moved outward from near the black hole into the cluster atmosphere. Their scale tells us that the outflows were not minor. The black hole's neighborhood has deposited enough power to reshape the gas far from the event horizon. This is one of the places where Phoenix A star becomes more than a mass estimate. It becomes a source of past work. Work, in the physical sense, is the right word. Energy has been transferred. Gas has been displaced. Bubbles have been inflated. The cluster core has been rearranged. No metaphor is needed for that to be powerful. A central black hole does not need intent to act on its environment. It only needs matter falling inward, magnetic fields and plasma to channel part of the released energy, and surrounding gas capable of receiving that energy over time. Then the next complication appears. Some of the gas is not staying hot. Cold gas in the central region changes the story. It means material has found a path downward in temperature and upward in density. Hot cluster plasma is too energetic and too diffuse to form stars directly. For stars to appear, gas must cool, condense, and gather until gravity can take over locally. Phoenix contains evidence that this is happening at an unusual rate. The central galaxy is not merely being heated by an active black hole. It is also building new stars from gas that has escaped the hot phase. That is where the system becomes genuinely difficult. If black hole feedback was simply failing, Phoenix would be a cooling flow story. If feedback was simply succeeding, Phoenix would be a quiet, central galaxy story. Instead, the observations point to both. The black hole is active enough to carve cavities, but the core is still producing stars. Cooling has not been shut down. Energy injection has not vanished. These facts have to coexist. The strongest narration should not resolve that tension too quickly. The tension is the value. Phoenix may be showing a phase in which feedback is operating but not strong enough, or not distributed in the right way, to prevent a large supply of gas from cooling. It may also show how jets and bubbles can lift gas, create local conditions for condensation, or help organize colder material around disturbed regions. The details are technical, but the central idea is clear. The black hole's influence is not a simple break. It is a reshaping force. A break has one job. Phoenix is not one job. The central engine can heat gas in one region, lift gas in another, stir the atmosphere, inflate cavities, and still leave pathways where gas cools and stars form. The cluster core is not responding as a single block. Different phases of gas react differently. Hot plasma, warm intermediate material, cold molecular gas, and young stars each reveal a different stage of the process. The black hole's activity does not erase that complexity. It helps expose it. This is where the story should stay concrete. Not creation from destruction. That is too easy. More precise. Outflows from the black hole push into hot gas. Pushed gas forms cavities. Around and beneath those structures, some material can cool or collect. Cooled gas can become fuel for star formation. The result is not a moral paradox. It is a chain of physical conditions. It is beautiful because it is specific. The more specific Phoenix becomes, the less it sounds like every other black hole story. Many black hole videos end up trapped in the same rhythm: darkness, gravity, devouring, terror, scale. Phoenix offers a better rhythm: estimate, correction, environment, feedback, cooling, star formation, growth history. Each step changes the object. The black hole begins as a possible record-breaking mass, but by now it has become a regulator under strain inside one of the universe's most revealing cluster cores. That phrase, regulator under strain, belongs to Phoenix. It avoids the weakness of calling the black hole a destroyer. It avoids the softness of calling it a creator. It shows the actual tension, central energy trying to control a gas supply that is still partly escaping into stars. In that tension, the title finds its deeper payoff. Phoenix. A star is not only enormous because of what it may weigh, it is enormous because the system around it behaves as if the center matters everywhere the gas is trying to change state. The next question is how such a center came to exist at all. A black hole like Phoenix A star cannot be born in one dramatic moment. A stellar mass black hole can begin with the death of a massive star. That story is violent, but at least it has a recognizable shape. A star runs out of usable fuel, its core collapses, and what remains may become dense enough that no light escapes. Supermassive black holes require a longer explanation. They are not made by one star. They are built through time, through feeding, through mergers, through the deep history of galaxies gathering matter toward their centers. Phoenix A star pushes that story close to its limit. If the upper estimate is right, then this black hole is not merely the result of ordinary growth stretched a little further. It is the product of an environment that allowed central mass to accumulate at an extreme level. That points back to the Phoenix cluster itself. Dense environments matter. A central galaxy inside a massive cluster has access to a different history than an isolated galaxy. It can grow through repeated mergers. It can sit at the bottom of a large gravitational well. It can collect stars, gas, and smaller galaxies over billions of years. Its central black hole can share in that accumulation. But growth still has resistance. Gas falling toward a black hole does not drop cleanly into the center. It carries sideways motion. It forms rotating structures. It heats up. It produces radiation. That radiation can push back. Outflows can remove fuel. Jets can disturb the gas that might have fed the black hole later. The same process that grows the black hole can make further growth harder. A central engine can regulate its own supply. That makes an ultramassive candidate more impressive, not less. It means Phoenix A star, if it truly lives near the 100 billion solar mass scale, must have passed through a long history of opportunity. Enough fuel had to reach the center, enough mergers had to build the central galaxy, and perhaps bring in other black holes. Enough time had to pass for the mass to accumulate. Enough feedback had to fail, fluctuate, or arrive too late to stop growth entirely. The object becomes a record of conditions that were unusually favorable, or unusually persistent, or both. This is why the mass estimate should feel old. Not old because the black hole has a visible face worn by time, but old because every solar mass added to it implies a past event. Some gas lost energy and fell inward. Some galaxy merged into the central one. Some smaller black hole may have spiraled into the growing center. Some active phase released radiation and outflows. Some quiet phase allowed fuel to return. A black hole at this scale is not just matter compressed. It is cosmic history made gravitational. The host galaxy carries part of that history in its own structure. Brightest cluster galaxies are often enormous because they grow where the cluster's gravity focuses long-term assembly. Over time, smaller galaxies can be stripped, absorbed, or merged. Stars are added to diffuse halos. The central galaxy becomes less like a normal spiral with a clean disk, and more like a vast accumulation of stellar history. Phoenix A belongs to that class, but with the added complication that its center is still unusually active in forming stars. That activity prevents the story from becoming archaeological only. Phoenix is not just a fossil of old mergers. It is still changing, at least in the ancient moment we observe. Cold gas is present, stars are forming, the active nucleus is disturbing the surrounding medium. The central black hole is part of an ongoing exchange. Past growth and present behavior overlap. That overlap gives the script a stronger spine than a simple origin story. The question is not only how Phoenix A star got so large. The question is how something so large continues to participate in its environment. A dead relic would be interesting. An active relic is better. It lets us see both the accumulated past and the physical present in the same system. The cluster gas is where the present becomes visible. In X-rays, the hot atmosphere shows structure. It is not a smooth, glowing fog. It carries cavities and disturbances linked to central activity. Those structures act like timestamps, not exact dates, but physical memories of energy injection. A jet outburst happens near the center. Energy moves outward. Gas is displaced. A cavity forms. Over time, the bubble rises or changes shape, while the cluster atmosphere responds. Long after the central engine shifts phase, the gas still preserves the event's outline. This is evidence with duration. A flash of light can vanish. A cavity can remain as a spatial record. It turns a moment of energy release into a structure that can be studied later. For a distant system like Phoenix, that matters. We cannot monitor millions of years directly. We rely on the fact that the cluster atmosphere keeps slow records. It stores consequences in shape. Cold gas stores a different kind of consequence. It tells us that some material has escaped the hot phase. This is not a minor detail. The hot, intracluster gas is too energetic to collapse directly into stars. It must lose energy. It must pass through intermediate stages. It must become denser. Detecting colder material near the core means the cooling path is not just theoretical. The gas has actually moved toward the conditions needed for star formation. Young stars are the final proof that the path matters. A star is not formed by intention or symbolism. It forms when gas becomes dense enough for gravity to win locally. In Phoenix A, the presence of strong star formation means the chain from hot atmosphere to cold fuel has advanced far enough to build new stellar populations. This is the point where the black hole's feedback becomes most interesting. It is clearly powerful, but it has not prevented the chain from operating. That tension should remain sharp. Do not soften it into the black hole creates stars. Do not flatten it into the black hole destroys stars. Phoenix is more exact than both. Its black hole-driven activity affects gas. Some of that influence heats and disrupts. Some may lift or rearrange material in ways that help cooling appear along certain paths. The resulting environment permits unusually strong star formation for a cluster center. The black hole is not a parent of the stars. It is part of the conditions through which their fuel is shaped. That difference is small in wording and large in trust. A serious narrator should not force a clean emotional role onto the black hole. It is not villain, creator, guardian, or god. It is a physical center in a massive system. Its power comes from gravity and accretion. Its influence moves through plasma, radiation, jets, and gas response. The awe comes from the chain, not from personification. The chain also protects the script from repeating itself. Instead of returning again and again to "this object is huge," the narration can move through functions. The black hole as accumulated history, the black hole as active engine, the black hole as feedback source, the black hole as measurement challenge, the black hole as clue to cluster evolution. Each return adds a new role. Each role tightens the title rather than echoing it. By now, Phoenix A star has stopped being only the answer to what is the biggest black hole. It has become a better question. What happens when black hole growth, cluster gas, and star formation meet at an extreme edge? At that edge, even familiar words begin to fail. Black hole sounds singular, as if the whole subject could be held inside one dark point. Galaxy sounds larger, because galaxies are what we use when stars are no longer enough. Cluster sounds like a collection, something made by gathering galaxies together. But Phoenix does not let those words stay separate. The black hole belongs to the galaxy belongs to the cluster. The cluster gas responds to the black hole. The stars forming in the galaxy depend on gas shaped by the cluster core. Each scale enters the next. That is the first reason Phoenix feels so hard to reduce. A normal explanation wants clean boundaries. Here is the black hole, here is the host galaxy, here is the cluster, here is the gas. But the physics does not respect the neatness of the labels. The black hole's feeding depends on gas reaching the center. The gas supply depends on cooling in the cluster core. Cooling depends on heating, turbulence, density, and time. Heating depends partly on black hole activity. the loop folds back into itself. Phoenix is not a straight line, it is a pressure cycle. The cycle begins with the cluster's hot atmosphere, spread between galaxies and held by the cluster's gravity. That gas is extremely hot, but heat is not the same as permanence. It radiates energy. When gas loses enough energy, it can cool. When it cools, it can become denser. Denser gas can sink, collect, and eventually form stars if local conditions allow. Some of it may also move toward the central black hole, feeding the engine that later sends energy outward. This is the basic tension of a cool core cluster. Too much cooling, and the central galaxy should build stars at a massive rate. Too much heating, and star formation shuts down. In many clusters, the balance leans towards suppression. Black hole feedback prevents most of the gas from cooling into stars. Phoenix stands out because the cooling side is unusually visible. Star formation is not a small afterthought. It is one of the system's defining features. That makes the central black hole more, not less, important. If Phoenix A star were inactive, the strong cooling might be easier to frame. If the core were quiet and the gas simply condensed, the story would move in one direction. But the central engine is active enough to disturb the hot atmosphere. The gas carries the marks of outflows. This means the system is not merely cooling because nothing stops it. Something is pushing back, and yet the cooling remains powerful. The result is a rare view of imperfect control. That phrase should stay near the heart of the script. Imperfect control is more specific than paradox and more useful than mystery. It tells the viewer exactly what is strange. The black hole appears to be regulating the cluster core, but not completely. Feedback is present, but star formation survives. Heating and cooling are not opposites frozen at two ends of a scale. They are interacting processes, and Phoenix is caught where neither has erased the other. This also gives the video a better emotional rhythm. Instead of repeating awe, the narration can tighten around conflict. Not artificial conflict, but physical conflict. Gas wants to cool because it radiates energy. The black hole returns energy through outflows. Cooling persists, stars form, the active center responds again. That tension has natural momentum. It does not need exaggeration. The listener can feel the system breathing without being told it is alive. A breathing metaphor can be useful once, if kept controlled. The cluster core is not alive, but it does pass through long phases of inflow and response. Gas cools inward, the black hole is fed, activity rises, energy moves outward, cooling changes. Over millions of years this can create a rhythm. In Phoenix, the rhythm seems uneven, as if the cooling has surged ahead of the usual regulation. The unevenness matters because it reveals process. A perfectly regulated system would be harder to understand from a single view. It would hide the struggle. Phoenix exposes the struggle by refusing quiet. It shows hot gas and cold gas in the same central environment. It shows feedback structures and star formation together. It lets us see the machinery while it is not fully settled. That machinery reaches back into the black hole's possible growth. A central black hole cannot become ultramassive without fuel across time. But fuel is exactly what feedback tends to regulate. This creates a long-term tension. The black hole grows by feeding, yet feeding can power the outflows that limit future feeding. Phoenix's current state may not tell the whole growth history, but it shows the kind of environment where growth and self-regulation are linked. The black hole is not simply a mass placed in the center after the fact. Its mass and its feedback are parts of the same cosmic negotiation. That negotiation includes the host galaxy. The central galaxy's stars record past assembly. Its current star formation records present cooling. Its active nucleus records central accretion. Its position in the cluster records the larger gravitational structure. Phoenix A is not just a container for Phoenix A star. It is the immediate arena where the black hole's history and the cluster's gas supply meet. This is where the narrative should sharpen the title again. A black hole larger than a galaxy sounds, at first, like a violation of scale. But inside Phoenix A, it becomes a statement about hierarchy collapsing. The central object may weigh as much as, or more than entire smaller galaxies, while living inside a galaxy that itself sits inside a cluster. The thing at the center is not spatially larger than its surroundings, but it may be massive enough to disturb our sense of what should be subordinate to what. The small centre carries a weight that competes with whole star systems. That reversal is stronger than shock. The largest visible structures are not always the dominant masses. The brightest things are not always the most important causes. The widest object is not always the deepest influence. Phoenix teaches all three at once. It takes the ordinary ladder, star, black hole, galaxy, cluster, and tangles it. A black hole can be smaller in extent than a galaxy, but heavier than many. A cluster can contain hot gas we cannot see with eyes, but must include to understand its mass and energy. A central galaxy can look old while forming stars intensely. Scale stops being a ladder and becomes a set of overlapping powers. This is the point where the script can slow down without losing pull. The viewer has earned the complexity. They now understand the mass, the measurement caution, the host galaxy, the cluster gas, and the feedback tension. The next movement should not add random facts. It should deepen the consequences of those facts. If Phoenix is a place where feedback fails to fully suppress cooling, then it helps answer why other massive galaxies are quiet. If Phoenix A star sits near the top of black hole mass estimates, then it pressures theories of how black holes grow. If its influence is visible through cluster gas, then it demonstrates how indirect evidence can reveal hidden architecture. 3 consequences. No clutter. The first consequence is about galaxy evolution. Massive galaxies do not keep forming stars forever at the rates their gas supply might suggest. Something slows them down. Black hole feedback is one of the major answers. Phoenix shows that the slowing is not automatic. The central engine can be powerful and still leave room for large-scale star formation under certain conditions. That makes Phoenix a stress test for the feedback story. The second consequence is about black hole growth. If a black hole can approach the Phoenix A star estimate, then central growth in cluster galaxies can be more extreme than ordinary examples imply. Such an object would not form by simple stellar collapse. It would represent accumulated feeding and merging across cosmic time. Phoenix does not merely show a big black hole. It hints at the long chain required to build the biggest ones. The third consequence is about knowledge itself. The most important object in the story is not directly seen. Its mass is inferred. Its influence is traced through gas and star formation. Its environment is assembled through many wavelengths. Phoenix is therefore not just a subject about black holes. It is a subject about how science learns from consequences when direct sight is unavailable. That last consequence prepares the ending, but it should not become the ending yet. There is still one more layer to tighten: time. Time is what turns Phoenix from a structure into a history. The light from the Phoenix cluster has crossed billions of years before reaching us. That means the system is not only far away, it is old information. We are not watching Phoenix A star in the present moment of the distant cluster. We are receiving a record from an earlier universe, carried by photons that left before Earth had anything like a human observer. Every observation is therefore doubled. It tells us what Phoenix was doing then, and what the laws of physics were allowing at that stage of cosmic history. That delay is not just a poetic detail. It changes the way the object should feel. A nearby black hole can seem like a place. Phoenix A star feels more like a preserved event. The cavities in its cluster gas are already records of older outbursts. The starlight from its central galaxy is already old by the time it arrives. The mass estimate points to an even deeper past of feeding and mergers. History sits inside history, ancient light carrying evidence of gas that preserved older activity from a black hole built by still earlier cosmic growth. This layered time prevents the script from going flat. The black hole is not frozen. The cluster core is not frozen. The image we receive is a slice through a moving system. The active nucleus may brighten or fade across long periods. Bubbles can rise through hot gas. Filaments can condense, fall, or feed star formation. The starburst may surge, decline, or be choked by later feedback. The exact state we observe is not the final form of Phoenix. It is one chapter that happened to send its light toward us. That makes the evidence more fragile and more valuable. Fragile, because we never hold the whole process directly. Valuable, because one well-read chapter can still reveal the plot. A cavity tells us that energy was injected before. Cold gas tells us that cooling has advanced. Young stars tell us the cooling mattered. An active nucleus tells us the center is still capable of driving feedback. A possible ultramassive black hole tells us the system has an unusually deep central history. The whole cluster becomes a time capsule written in several physical languages. The strongest of those languages is not light alone, it is contrast. Hot gas against cold gas, quiet regulation against extreme star formation, enormous mass against uncertain measurement, tiny horizon compared with the cluster, but huge influence compared with ordinary intuition. Old stellar populations beside fresh stars. Each contrast sharpens the central claim without repeating it. Phoenix is not memorable because every fact says the same thing. It is memorable because every fact changes what the previous fact meant. The mass makes the cluster feel different. The cluster makes the mass feel earned. The star formation makes the feedback feel incomplete. The feedback makes the star formation feel surprising. The uncertainty makes the headline feel more serious. The distance makes all of it feel like a message from deep time rather than a nearby spectacle. That is the structure the script should protect. No loose facts, no ornamental scale comparisons, no repeated darkness language. Each idea must pay rent. If a paragraph mentions the event horizon, it should clarify boundary, not mood. If it mentions 100 billion suns, it should do new work: mass comparison, growth history, measurement uncertainty, or influence. If it mentions stars, they must connect to cooled gas. If it mentions jets, they must connect to cavities or feedback. If it mentions distance, it must connect to time and observational limits. This discipline matters because Phoenix is already dramatic. Extra drama weakens it. A black hole does not need to be called a monster when its possible mass already rivals galaxies. The cluster does not need to be called impossible when its gas, cavities, and star formation are enough. The uncertainty does not need to be hidden when careful uncertainty gives the narration authority. The subject becomes stronger when the language stops trying to perform awe and lets the chain of consequences create it. The chain now runs clearly. A possible ultramassive black hole sits at the center of Phoenix A. Phoenix A sits at the center of the Phoenix cluster. The cluster core contains hot gas that should cool under the right conditions. The central black hole's activity injects energy into that gas and carves cavities. Cooling still proceeds strongly enough to produce cold material and intense star formation. This makes Phoenix a rare environment where black hole feedback, instead of appearing as a completed shut-off switch, is visible as a contested process. That single paragraph is the spine. Everything else should deepen one piece of it. The growth history deepens the black hole. The multi-wavelength observations deepen the evidence. The cooling flow problem deepens the gas. The star formation deepens the contradiction. The event horizon deepens the meaning of hidden mass. The distance deepens the time. The ending should not add a new topic. It should let the whole chain resolve into one clear realization. The largest object in the story is not understood by staring at its darkness, but by reading the system that darkness has helped shape. That realization is stronger than fear. Fear is too easy with black holes. It arrives quickly and fades quickly. Phoenix needs something more durable, a slow adjustment in the viewer's sense of scale. At first, the viewer thinks scale means physical width. Then scale becomes mass. Then it becomes influence. Then it becomes history. Finally, scale becomes interpretation, the amount of reality that must be rearranged in the mind to make one hidden object understandable. That is the final escalation path. The narration can now move toward a larger, quieter statement without becoming generic. Not, "we are small," not, "the universe is mysterious." Those are true, but overused. The more specific residue is this. Phoenix A star shows that the universe can place its greatest weights where sight cannot follow, and still leave enough evidence in gas, stars, and time for a small observer to reconstruct the hidden cause. That sentence can be earned only after the structure is tight. Before the end, one last physical return should happen. Bring the viewer back to the cluster core itself. Not the headline, not the abstract meaning, the place, a central galaxy, hot gas glowing outside human sight, cavities where energy has pushed matter aside, cold gas collecting along disturbed paths, new stars forming where the cooling has gone far enough, and inside all of it, the possible ultramassive black hole, not visible, not directly weighed in a simple way, but present as an explanation the system keeps requiring. That image contains the whole script without summarizing it mechanically. It also prevents the ending from becoming detached philosophy. The final meaning must stay attached to Phoenix. The viewer should not feel they have been moved into a generic cosmic reflection. They should feel they are still inside this specific system, with this specific black hole, this specific cluster gas, this specific tension between feedback and star formation. Then the last movement can narrow. From cluster to galaxy, from galaxy to center, from center to event horizon, from event horizon back outward to evidence. That loop completes the script's deeper structure. We began with mass, moved outward to consequence, and returned to the hidden center with better eyes. The black hole gives nothing back from within the horizon, but outside the horizon, the universe has not been silent. It has been speaking in displaced gas, in cooling material, in new stars, and in the long delay of light. That is the strange generosity of a system built around a boundary of no return. The black hole itself removes information from the outside universe once matter crosses the horizon, but the process around that loss creates information everywhere else. Before gas disappears, it can shine. Before energy is absorbed, some of it can escape. Before a cluster core settles, its atmosphere can preserve the marks of disturbance. Phoenix A star hides the final interior, but the surrounding system becomes almost overfull with clues. This is where the viewer's first image should be completely changed. At the beginning, Phoenix A star may have seemed like a giant object waiting to be measured. Now it should feel more like the central missing term in a vast equation. The cluster core does not make the same sense without it. The active nucleus needs a power source, the cavities need an engine, the feedback needs a center. The cold gas and star formation need to be understood against the energy that should have limited. The possible 100 billion solar mass estimate needs the environment that could plausibly build such an extreme object. The black hole is not merely inside the system, it helps organize the questions the system asks. That distinction matters because a loose script would keep expanding until Phoenix disappears into general cosmology. The stronger path is to make every expansion return with sharper pressure. When we move outward to the cluster, we are not leaving the black hole, we are finding its evidence. When we move backward into growth history, we are not leaving the present, we are explaining how such a center could exist. When we move into star formation, we are not softening the darkness. We are showing why the feedback problem is not simple. Each outward step must tighten the center. Time does that better than almost anything. The black hole's possible mass is a memory of growth. The central galaxy's size is a memory of assembly. The cavities are memories of energy release. The cold gas is a memory of cooling. The young stars are cooling made visible. The light reaching Earth is memory crossing cosmic distance. Phoenix is not one moment. It is a stack of pasts arriving together. That is why the system feels so dense, even before we add poetry. A nearby object can be described by where it is. Phoenix has to be described by what has happened. It is not enough to point. The pointing itself is delayed by billions of years. The cluster we see is an earlier state. Its current state, if we could somehow know it, would belong to light that has not reached us yet. So every observation has a built-in humility. We are not watching the object now. We are reading a message from then. But that does not make the message weak. Old light can carry fresh understanding. The laws it reveals are not old in the same way. Gravity still gathers matter. Gas still heats and cools. Radiation still carries energy. Black holes still grow, feed, and influence their surroundings. Phoenix is light left long ago, but the physics it exposes belongs to the same universe we inhabit now. Distance turns the evidence into history. It does not turn it into myth. That point helps keep the narration grounded. The viewer should not feel that Phoenix is a fantasy realm where impossible things happen because space is strange. The opposite is stronger. Phoenix is strange because familiar physics, scaled beyond ordinary experience, produces outcomes that feel almost impossible. Gravity, gas, radiation, and time are enough. No magic is required. No alien explanation is needed. No dramatic secret has to be invented. The real system already carries more force than the invented one would. A black hole grows by ordinary physical processes pushed to extraordinary extremes. A cluster atmosphere glows because hot plasma emits X-rays. Cavities form because outflows push gas aside. Cold gas appears when material loses enough energy. Stars form when gravity wins inside dense regions. Each piece is understandable. The total result is what overwhelms. That is the kind of depth the script should keep choosing. Simple pieces, enormous arrangement. If the listener can understand each step, they can follow the full scale without strain. The sun becomes a unit of mass. The event horizon becomes a boundary of no return. The cluster gas becomes a hot atmosphere. Feedback becomes energy sent back into that atmosphere. Cooling becomes gas losing energy and becoming denser. Star formation becomes the final sign that cooling has gone far enough. None of those explanations need jargon. Together, they create a high-level understanding of one of the most extreme systems in astronomy. The key is not to overfill. Phoenix tempts excess because it has so many large facts. One could mention redshift, luminosity, cooling rates, cavity power, stellar mass, molecular gas, accretion physics, cluster mass, dark matter, and black hole scaling relations until the listener is buried. But a great narration is not a storage room, it is a route. The route here is narrow by design. Mass becomes uncertainty. Uncertainty pushes us to environment. Environment reveals feedback. Feedback meets cooling. Cooling produces stars. Stars force us to reinterpret the black hole's role. The final return makes the title more precise than it first appeared. That route must stay clean. The dark matter halo can appear briefly only to explain why the cluster is a bound system. The event horizon should appear only when the boundary matters. The mass estimate should appear only when its role changes. The instruments should appear only as extensions of human sight. The star formation should never drift into a separate galaxy evolution lecture. Everything has to point back toward Phoenix A star as an extreme central object made meaningful by its effects. That is how repetition is avoided. A repeated word can be edited easily. A repeated function is more dangerous. If 5 paragraphs all say, "The black hole is hidden but influential," even with different language, the script slows. Each return must modify the idea. Hidden but required by cavities. Hidden but implied by central activity. Hidden but limited by measurement. Hidden but historically built. Hidden but causally present in cooling and feedback. Same center, different pressure. The viewer should feel accumulation without redundancy. This also changes the ending strategy. The final message should not summarize the journey in list form. It should re-enter the cluster core with everything now understood. At the end, the central galaxy should feel different than it did at the start. The hot gas should no longer be background. The cavities should no longer be decoration. The star formation should no longer be a surprising side note. The black hole should no longer be a headline number. All of them should lock into one image. A distant cluster, a central galaxy, a possible ultramassive black hole. Hot gas pushed aside, cold fuel gathering, stars forming where the regulation is incomplete, light arriving late, humans reading the traces. That image is enough. It does not need a final line about the universe being vast. It does not need to tell the viewer they are small. It does not need to force awe into a slogan. If the script has done its work, the viewer already feels the changed scale. They know the largest thing in the story is not just a dark mass. It is the web of consequences around that mass, preserved across gas and time. And before that final image can land, the narration should make one last correction. Phoenix A star is not important because it gives us a clean answer. It is important because it gives us a demanding case. The mass estimate may be refined. The feedback model may become more detailed. Future observations may clarify the cooling path. Better instruments may sharpen what we can say about the central black hole. But the system will remain valuable because it already shows the problem in action: how the largest black holes and the largest galaxies regulate, fail, grow, and leave evidence in the space between galaxies. That makes Phoenix less like a finished monument and more like an open page in the physics of extreme structure. The page is difficult, but it is readable. Readable does not mean finished. That is the right feeling to carry into the final stretch of Phoenix. The system is not a solved diagram with every arrow labelled forever. It is a rare case where the important arrows are visible enough to follow and difficult enough to keep studying. The central black hole candidate may be refined. The cooling model may become sharper. The role of jets may be mapped in more detail. The star-forming gas may be traced through more stages. But the core lesson is already clear. Phoenix is not a simple object. It is an extreme relationship between hidden mass and visible consequence. That relationship begins with gravity, but it does not stay there. Gravity gathers matter toward the center. Accretion releases energy. Outflows push into gas. Gas changes state. Stars form. The black hole grows, then regulates the material that could feed it again. This is not a neat circle. It is a rough, delayed exchange, spread across distances so large that the word nearby loses its ordinary meaning. Yet the chain is still understandable, because each step leaves a trace. The trace is what matters. A cavity is not just a gap, it is work done on gas. Cold material is not just another component, it is evidence that cooling has survived. Young stars are not just beautiful, they are proof that gas has crossed a threshold. An active nucleus is not just a bright center, it is a sign that matter near the black hole is releasing energy before final loss. A mass estimate is not just a number, it is an attempt to measure the weight required by an extreme central system. Each trace should change the viewer's sense of the title. At first, 100 billion suns feels like the whole promise. By now it should feel like the first pressure point. The number is still huge, but it is not enough by itself. A number can astonish and then vanish. Consequence remains. Phoenix. A star matters because the cluster core behaves like a place where an enormous central engine has been active, where gas is not behaving quietly, and where the usual story of black holes suppressing starbirth is under strain. That strain is more memorable than size alone. Size without tension becomes scale wallpaper. Tension gives the scale direction. Phoenix is massive but also uncertain, active but not simply suppressive, distant but readable, dark at the center but surrounded by visible effects, old in the light we receive but full of processes that reveal motion. Each contrast pulls against the others. The script should let those contrasts do the work rather than announcing wonder again. The strongest return now is to the human problem of knowing. We cannot fly to Phoenix. We cannot hover near its central galaxy. We cannot watch the black hole's feeding cycle unfold across millions of years. We cannot place the object on a scale. We cannot see inside the event horizon. Almost every direct instinct fails. Yet the system is not beyond knowledge. It is only beyond simple sight. That difference is essential. Simple sight would show only part of the universe. Human eyes would miss the X-ray atmosphere. They would miss much of the cold gas. They would not resolve the central mass. They would not know which regions were heated, lifted, or displaced. Instruments turn the invisible into evidence, but evidence still needs interpretation. Phoenix becomes real through that partnership. Machines extend the senses, physics organizes the signals, caution keeps the conclusions honest. This is where the viewer should feel included, not erased. The point is not that humans are tiny and therefore irrelevant. That conclusion is easy and tired. The stronger point is that a small species can learn to read a system that no body could experience directly. We are not built to see cluster gas, but we can detect it. We are not built to feel radio jets, but we can map them. We are not built to wait through cluster cycles, but we can read cavities as records of earlier activity. Phoenix is far beyond us physically, yet not beyond us intellectually. That is a better humility. It does not lower the viewer, it sharpens their respect for the method. Awe comes not only from the black hole's mass, but from the fact that such mass can be inferred at all. The universe leaves signs. Human beings learn to read signs. That is the quiet bridge between a planet-bound observer and a black hole candidate billions of light years away. The bridge should not be made sentimental. The light from Phoenix did not travel for us. The gas did not glow for us. The cavities were not carved as messages. The stars did not form to symbolize renewal. But when the signals arrived, we had become capable of asking what physical chain produced them. Meaning does not have to be intended by the universe to be real for the mind that understands it. The meaning is in the relation. Evidence, law, inference, recognition. That recognition now brings us back to the title one last time before the close. Phoenix A star may be larger than a galaxy in the way that matters to this story, not as a giant visible disk, but as a possible galaxy mass concentration hidden in the center of a system that keeps revealing its influence. It may outweigh many galaxies in stellar mass. It may hold a horizon vast compared with anything near Earth. It may record a growth history built through mergers and feeding. But the final measure is not only how much mass is inside the boundary. It is how much of the surrounding system becomes understandable once that boundary is included. That is the cleanest payoff. The black hole is large because it changes interpretation. Remove it, and the Phoenix core fragments into disconnected clues. Include it, and the clues begin to align. Active nucleus, outflows, cavities, hot gas, cold gas, star formation, feedback under strain, extreme central growth. The black hole does not explain every detail alone, but it gives the system one of its necessary centers. Necessary, not visible. That phrase should carry the final movement. The largest cause in the story is not the brightest object. The most important boundary is not a surface we can see. The most powerful evidence is not one photograph, but a pattern. Phoenix A star becomes unforgettable when the viewer stops looking for a black sphere and starts seeing a cluster core arranged around an unseen weight. The ending can now narrow without shrinking. Return to Phoenix A itself. A central galaxy in a distant cluster, old enough to carry the signs of long assembly, active enough to keep changing. Around it, hot gas glows beyond human sight. Within that gas, cavities mark old energy. Colder material gathers where cooling has gone far enough. Stars form from that material, not as decoration, but as proof that the cluster's regulation is incomplete. At the center, the black hole candidate remains hidden, possibly immense. Not fully pinned down by measurement, but impossible to ignore. That image has no need for exaggeration. It is already extreme in mass, in distance, in temperature, in time, and in consequence. The final words should not inflate it, they should let it settle. A star is not a monster waiting in the dark. It is not a cosmic trophy. It is not just a number in a ranking list. It is a hidden central fact inside a living-looking, physically lawful system where matter falls inward, energy moves outward, gas cools, stars form, and ancient light arrives carrying the record. And after all the scale, that is what remains. Not fear, but a changed way of reading. The universe does not always place its greatest weights where the eye can see them. Sometimes it buries them at the center, behind a boundary that returns no light and lets the surrounding gas write the evidence. And that evidence is not a whisper. It is written across scales so large that even the word around begins to stretch. Around Phoenix A star, there is the inner region where matter loses energy before the final fall. Around that, the active nucleus channels power outward. Around that, the central galaxy holds old stars and new star formation in the same structure. Around that, the cluster core contains hot gas, cavities, and colder material tracing the struggle between heating and cooling. Around that, the Phoenix cluster sits inside the larger cosmic web, held by gravity and dark matter across distances that make a single galaxy feel local. Each layer keeps the center present without repeating it. The black hole is not mentioned again, merely because it is dramatic. It returns because each scale demands it in a different role. Near the horizon, it is a boundary. In the accretion region, it is an engine. In the central galaxy, it is a growth record. In the cluster gas, it is a feedback source. In the history of structure formation, it is an endpoint of long accumulation. That is how the script avoids circling the same idea. The object stays the same, its function changes. Function is what makes Phoenix feel real. A mass estimate can feel abstract. A function makes it physical. If Phoenix A star powers outflows, those outflows can do work. If they do work, the gas records the work. If gas is lifted, displaced, or compressed, its future changes. If part of it cools, stars can form. The black hole's importance is therefore not a mood, it is a causal chain. That chain also gives the viewer a way to remember the whole story. Not by memorizing every observation, but by following the direction of energy. Matter inward, energy outward. Gas disturbed. Cooling partly survives. Stars form. The center grows and responds. That pattern is simple enough to hear once, and deep enough to carry the title. It turns 100 billion suns into movement. Movement matters because the biggest danger in a subject like this is stillness. A huge black hole can become a statue in the imagination, a record holder, a cosmic object placed on display. Phoenix should never freeze that way. Its power is in exchange. The cluster core is not quiet. The central galaxy is not finished. The gas is not only hot. The black hole is not only dark. Everything important is in transition. This transition happens too slowly for a human witness, but not too slowly for evidence. A person can watch a cloud move across the sky and understand weather because the motion happens within minutes. Phoenix's motions are not given to us that generously. A cavity can take millions of years to rise. A cooling flow can unfold across immense spans. A black hole's feeding cycle can change over periods longer than civilizations. A central galaxy can grow through events separated by ages. Yet the system preserves states from different moments, letting us reconstruct a process without seeing the whole movie. That is a useful image if kept clean. Not a movie playing before us, but a single frame with motion written into it. The frame contains marks that cannot be explained by stillness. Cavities imply previous outflows. Cold gas implies previous cooling. Star formation implies gas that has crossed into dense states. The active nucleus implies current or recent central fueling. The extreme mass estimate implies long-term assembly. Every feature points backward and forward at once. Phoenix is a snapshot with arrows inside it. Those arrows should carry the final third of the narration. One arrow points inward toward growth. Gas and mergers build central mass. Another points outward toward feedback. Accretion powers energy release into the gas. A third points downward in temperature, from hot plasma to cooler material. A fourth points upward in consequence, from cold gas to new stars. The tension between these arrows gives Phoenix its structure. The script can move through them without needing artificial section breaks. This is also the right place to correct one last common intuition. People often imagine black holes as endings because the event horizon is final for anything crossing inward. That is true locally, but outside the horizon, black holes can create beginnings in the indirect sense that their activity changes the conditions from which new structures arise. Not because the black hole intends to create, and not because it sends anything back from within the horizon. It is simpler and more powerful than that. Matter falling toward a deep gravitational well releases energy. That energy enters the environment. The environment responds. Some responses suppress collapse, others rearrange material. Under the right conditions, cooled gas still forms stars. So the black hole is an ending wrapped in a system that continues. Phoenix A star makes that distinction necessary. Without it, the viewer would leave with the old image, a dark object eating matter. With it, the viewer leaves with a sharper picture, a central boundary of no return, surrounded by processes that heat, move, cool, and build. The black hole is not softened. It remains absolute at the horizon. But its environment is not dead. That is the tension. The tension must not be turned into sentiment. New stars forming near the centre do not make Phoenix hopeful in a human sense. They make it physically richer. The point is not that creation conquers darkness. The point is that the same system can contain irreversible loss at the event horizon and star formation in the surrounding galaxy. The universe does not need our emotional categories to be interesting. Its processes overlap because the physics allows them to. That precision protects the ending. A lesser ending would say that even in darkness there is light. That is too generic, too easy, too transferable to any topic. Phoenix deserves a more specific final thought. In this cluster, the deepest darkness is understood through what the gas and stars have become outside it. The event horizon hides the centre, but the cluster core preserves the consequences. Knowledge does not cross the horizon, it gathers around it. That idea should land slowly, because it also explains the human achievement. We are not learning Phoenix by direct possession. We are not opening the black hole. We are not resolving every orbit near its centre. We are reading the effects that remain outside the forbidden boundary. Our instruments do not defeat the horizon, they work around it. They turn the surrounding universe into a measuring device. The cluster itself becomes the instrument. Hot gas measures energy injection through its cavities. Cold gas measures the survival of cooling. Young stars measure the success of collapse. The central galaxy measures long-term assembly. The distance measures time. The mass estimate measures our attempt to connect all of this to the central object. Phoenix A star is not weighed by one simple scale. It is weighed by a system of traces. That is why the final version of the title should feel earned. 100 billion suns is not a shout anymore. It is the name of a possibility with consequences. Larger than a galaxy is not a cartoon image anymore. It is a way of saying that a compact hidden centre may carry galaxy-level mass and cluster-level importance. Phoenix A star becomes larger in the viewer's mind, not because the language inflated it, but because the evidence expanded the meaning of size. Size as mass, size as history, size as influence, size as necessity. These four meanings can now converge. The mass is the proposed 100 billion solar mass scale. The history is the growth through mergers and feeding in a central cluster galaxy. The influence is the feedback written into hot gas and cooling material. The necessity is the way the system becomes more understandable once the black hole is included. That convergence is the payoff. The script should end by letting the viewer hold all four at once, and the final image should be quiet enough to keep them. Quiet does not mean small. A quiet image can hold more force than a loud one if it contains the whole chain. Phoenix does not need to end with a cosmic scream. It needs to end with the viewer seeing the cluster differently. A central galaxy, not as a lonely island of stars, but as the bright core of a larger atmosphere. Hot gas, not as background, but as the material that remembers energy. Cavities, not as empty shapes, but as records of black hole activity. Cold gas, not as a side note, but as the proof that cooling has survived. New stars, not as decoration, but as the outcome of that survival. And at the centre, the black hole. Not visible, not simple, not fully settled as a final number, yet too important to remove. That is the line Phoenix keeps walking. It gives us enough evidence to speak, and enough uncertainty to speak carefully. The 100 billion solar mass estimate is powerful, because it points toward the upper extreme of what black holes may become. But the cluster environment is powerful because it shows why the object matters even beyond the estimate. If future measurements shift the number, the system still remains a rare case of feedback, cooling, and star formation caught together. If the estimate holds near its famous scale, then Phoenix A star becomes one of the most staggering central masses ever seriously proposed. Either way, the core lesson survives. The universe does not always reveal importance through brightness. It can hide importance behind a horizon and let consequence do the revealing. Around Phoenix A star, consequence is everywhere. It is in the gas pushed aside. It is in the cooling that refuses to vanish. It is in the stars forming where the simple model would expect stronger suppression. It is in the growth history implied by such an extreme central galaxy. It is in the way multiple telescopes, each blind in a different way, must work together before the system comes into focus. That focus is not a photograph, it is an understanding. A photograph can show shape, understanding shows dependence. We understand Phoenix more deeply when we see what depends on what. Star formation depends on cold gas. Cold gas depends on cooling. Cooling struggles against feedback. Feedback depends on central activity. Central activity depends on matter near the black hole. The black hole's possible mass depends on a long history of growth. That growth depends on the cluster environment that gathered matter toward the center. The system becomes less like a picture and more like a chain under tension. That chain is the answer to the title. A black hole can be larger than a galaxy, not only because the mass estimate may exceed the stellar mass of smaller galaxies, but because a compact central object can become one of the controlling facts of an environment far larger than itself. Phoenix. A star is not stretched across the cluster like a shadow. It is embedded at the center as a cause. Its boundary is hidden, but its role is distributed. This is the final correction the viewer should carry. The biggest thing in the story is not the widest thing. The most powerful thing is not necessarily the brightest. The darkest object is not necessarily the least active. A black hole can be physically compact compared with a galaxy and still force galaxy-scale thinking. It can give nothing back from within its horizon and still surround itself with evidence. It can mark an end for falling matter and still participate in a system where stars are being born. That last contrast should stay precise. The black hole does not create stars from within the darkness. It does not send material back from the horizon. It does not decide to build anything. The stars form because gas outside the black hole has cooled and condensed. The black hole matters because its activity changes that gas, heating some of it, moving some of it, carving pathways through some of it, failing to suppress all of it. Creation and destruction are not balanced like symbols. They are connected through matter, energy, and time. The physical truth is stronger than the symbolic one. A cluster core does not need meaning to be meaningful. Its processes have no intention, yet they can change the way a human mind understands reality. Phoenix. A star turns a familiar hierarchy inside out. We think of galaxies as vast and black holes as points within them. Then we meet a candidate whose possible mass competes with galaxies. We think of darkness as absence. Then we find a central darkness surrounded by measurable effects. We think of starbirth as far from black hole violence. Then we find cooling gas and new stars in a core shaped by feedback. Each reversal is earned by evidence, not by drama. That is why the final emotion should not be panic or triumph. It should be a clean astonishment, the kind that does not need to raise its voice. The viewer should feel that the universe has become more exact, not merely bigger. A star does not expand the imagination by breaking physics. It expands the imagination by showing how much physics can do when given enough mass, enough time, and the right environment. Given a massive cluster, gravity can gather galaxies and gas into one bound structure. Given a central galaxy, mergers can build enormous stellar mass. Given gas and time, some material can reach the center. Given a black hole, accretion can release energy before matter is lost. Given jets and outflows, that energy can reshape hot gas. Given cooling, some gas can become dense. Given dense gas, stars can form. Given distance, all of this can arrive to us as ancient light. One chain, no miracle required. And yet the result still feels miraculous in the ordinary human sense, because our daily world gives us no preparation for it. We know heat from fire, not from plasma spread between galaxies. We know darkness from night, not from an event horizon. We know weight from objects we can lift or drop, not from a central mass counted in billions of suns. We know birth from living things, not from stars forming in a disturbed cluster core. Phoenix takes familiar words and places them under conditions that make them almost new. That is why the story lasts. Not because Phoenix A star is a number to memorize, not because it is a monster to fear, not because the title can be shouted louder than other titles. It lasts because it changes the shape of a basic intuition, that the universe is mostly understood by looking at what shines. Phoenix says no. Sometimes the deepest cause does not shine at all. Sometimes it is known by what the shining material has become around it. The final view should be almost still. A cluster far away. A central galaxy with old stars and new ones. A hot atmosphere glowing in invisible light. Cavities where energy has done work. Cold gas gathered from cooling paths. A possible ultramassive black hole at the centre, carrying a mass that turns the sun into a small unit of accounting. Light from all of it travelling for billions of years, arriving here, where a species born around one ordinary star learns to read the traces. Nothing about that needs to be exaggerated. The event horizon remains closed. The exact mass remains a serious estimate, not a simple trophy. The feedback remains complex. The star formation remains unusual. The cluster remains distant. The evidence remains indirect. But together, those limits do not diminish Phoenix. They make it real. They keep it from becoming a cartoon. They let the awe come from the structure itself. Phoenix A star is not the darkness that explains everything. It is the hidden centre that makes the surrounding evidence fall into a deeper order. And that is the image to leave with. Not a black hole drawn larger than a galaxy, but a galaxy cluster quietly shaped around something that gives back no light from within, while the gas outside it writes the story in heat, motion, cooling, and stars. That deeper order is not neat, and it should not be made neat. Phoenix A star is most powerful when the script allows a little roughness to remain. Not confusion, roughness. The kind that belongs to real systems where several processes operate at once. The black hole may be enormous, but its exact mass is difficult to pin down. The feedback is powerful, but not perfectly suppressive. The gas is hot across the cluster core, yet colder material survives. The central galaxy is old in structure, yet active in star formation. The light is ancient, yet it teaches current physics. That is why the subject resists a clean ending too early. A simple ending would say the black hole is bigger than we imagined, but that was only the first doorway. Another would say it destroys and creates at the same time. That sounds elegant, but it is too vague. A stronger ending keeps the physical chain intact. Accretion powers outflows. Outflows disturb gas. Disturbed gas changes its cooling path. Some cooling survives. Stars form. The central black hole remains both a regulator and a source of strain. The awe is not in a contradiction. It is in the mechanism. Mechanism gives wonder a spine. Without it, the script becomes atmosphere. With it, every image has weight. A cavity is no longer just a hollow in X-ray gas. It is energy made visible after moving outward from the central engine. A cold filament is no longer just a beautiful structure. It is gas that has escaped the hottest state and moved closer to star-forming conditions. A young star is no longer just a hopeful symbol. It is proof that local gravity has overcome pressure and motion. Phoenix becomes memorable because its beauty keeps explaining itself. That is the standard the final movement has to meet. It cannot drift into generic scale. It cannot talk about the universe as if every cosmic subject ends in the same place. Phoenix has a specific residue, a hidden ultramassive candidate whose importance is measured through a cluster core that has not settled into silence. The final emotion should come from that specificity, not from telling the viewer to feel small, but from letting them feel how much had to be learned before one invisible center could become understandable. The learning itself is part of the story. For most of human history, the sky was a surface of lights. It had motion, rhythm, seasons, omens, navigation, beauty. But it did not reveal hot gas between galaxies. It did not reveal event horizons. It did not reveal dark matter halos holding clusters together. It did not reveal that some galaxies carry black holes millions or billions of times the mass of the Sun. Those truths were not waiting in plain sight. They required instruments, mathematics, patience, and the willingness to believe evidence that did not look like everyday seeing. Phoenix sits near the far end of that transformation. To understand it, the eye alone is almost useless. A person could stare toward the Phoenix cluster and receive none of the important information directly. The hot gas speaks in X-rays. The cold material may speak through radio or millimeter emission. Dust-obscured star formation needs infrared vision. The central black hole's possible mass comes through inference, scaling, modeling, and environment. The system is not hidden because it is empty. It is hidden because reality uses more channels than the human body can receive. That makes Phoenix an argument for extended perception. A telescope is not just a stronger eye. It is a way of becoming sensitive to a different part of reality. X-ray observatories let us see gas too hot for visible light. Radio arrays let us trace structures and materials that ordinary sight misses. Infrared telescopes uncover regions where dust would block visible light. Each instrument changes the universe from a picture into a physical map. Phoenix only becomes Phoenix when those maps overlap. And even then, the center keeps something back. The event horizon remains the point where inquiry from outside stops. Not because our instruments are poor, but because the boundary is physical. No telescope can receive light from inside a region that sends none out. No future sensitivity changes that basic fact. We can improve the surroundings. We can sharpen the models. We can measure the effects better. But the interior remains sealed from the outside universe. That sealed center is what gives the surrounding evidence its power. If the black hole could be opened like a box, the story would be different. Instead, knowledge has to gather around the limit. The gas becomes the witness. The jets become the handwriting. The cavities become the record. The stars become the consequence. The cluster becomes the measuring instrument. A star is not only an object inside the cluster, it is the reason the cluster must be read so carefully. The script should let that idea breathe without repeating it. One way to do that is to change the final scale from quantity to dependence. At the start, the viewer measures Phoenix A star against the Sun, later against Sagittarius A star, then against galaxies. Now the final comparison should be dependency. How many parts of the system depend on including the black hole in the explanation? The answer is what makes the object feel immense. Its size is not just in mass. Its size is in the number of clues that bend toward it. That is a fresh, final form of larger. A body can be large by taking up space. A cause can be large by organizing effects. Phoenix A star is the second kind in this story. Its possible mass gives it the headline. Its causal reach gives it the after effect. The viewer should leave not with a black disk in the mind, but with a cluster core quietly reorganized around an unseen center. This also keeps the channel voice from becoming repetitive. The ending should not be, look at the night sky differently. Phoenix is not visible that way. It should not be, we are tiny. That is too broad. It should not be, darkness contains creation. That is too portable. The ending has to belong only here, to a black hole candidate in the Phoenix cluster, to hot gas and cavities, to cooling that survives feedback, to a mass estimate that is huge but carefully held, to the act of reading consequence where direct sight fails. That specificity is what makes the final emotion honest. The viewer does not need to be told that the universe is mysterious. They should feel that mystery has become structured. They have learned the pieces. They have followed the chain. They have seen why the headline was incomplete and why the corrected version is stronger. Now the final movement can be simple. A distant cluster, a central galaxy, an active nucleus, hot gas, cavities, cold fuel, new stars, a possible black hole of almost unbearable mass, ancient light arriving late, human instruments translating what the body cannot sense. The image holds because every piece has already been earned. From there, the ending can turn inward, not towards sentiment, but toward recognition. The universe is not obligated to make its most important causes visible. It often does not. But it does leave relationships. Things move. Gas changes. Light shifts. Structures form. Patterns repeat. And when enough of those relationships point toward a hidden center, knowledge can reach the edge of what cannot be seen. Not beyond the edge. To the edge. That distinction matters. We do not conquer Phoenix A star. We do not solve it completely. We do not turn its horizon transparent. We do not own the cluster by naming it. We learn enough to respect the structure. We learn enough to say that the famous number, if close to true, is only the beginning of the strangeness. We learn enough to see why the surrounding gas matters as much as the darkness itself. And that is where the script should finally settle, on the fact that Phoenix A star gives no light back from its deepest boundary, yet its existence may be written across an environment larger, brighter, hotter, colder, older, and more active than the first image of a black hole could ever contain. And that is why Phoenix A star should not be remembered as a single dark point. A point is too small an idea for it. Even if the event horizon is the central fact, the story we can actually know is spread outward. It is spread through the active nucleus, through the surrounding gas, through the cavities left by outflows, through the colder material that has escaped the hottest phase, and through the stars forming in a place where the central black hole should make that process harder. The hidden boundary is only the deepest part of the structure. The visible evidence is the larger body of the story. That body is not smooth. It is uneven because the process itself is uneven. Feedback does not arrive everywhere with the same strength. Gas does not cool everywhere at the same rate. Jets do not deposit energy as a perfect sphere. Star formation does not begin evenly across a galaxy. The cluster core is a place of gradients, hotter and cooler, denser and thinner, disturbed and calmer, old stellar populations and younger light. Phoenix matters because the gradients are strong enough to reveal the conflict. The conflict is not between good and bad forces. It is between physical tendencies. Gas radiates energy and can move toward cooling. Gravity encourages denser material to collapse. The active center sends energy outward. Pressure resists collapse. Motion and turbulence stir the gas. Some regions remain hot, others cross into colder states. From those colder states, stars can form. The black hole's role is not a character role. It is a physical role. It changes the conditions under which those tendencies compete. That role is why the object becomes larger in meaning than its own horizon. The horizon defines loss. Feedback defines reach. Growth defines history. Measurement defines uncertainty. Together, they make Phoenix A star more than a candidate for a mass record. It becomes a test case for how the largest central black holes interact with the largest atmospheres bound by gravity. That is a rare combination. Many black holes can teach us about horizons. Many clusters can teach us about hot gas. Phoenix forces those lessons into one frame. One frame, but not one wavelength. In visible light, the central galaxy and its stars matter. In X-rays, the hot gas becomes the dominant story. In radio and millimeter light, jets and cold gas become clearer. In infrared, dust-hidden star formation and intermediate temperature material can emerge. Each view changes what counts as obvious. The black hole itself remains unseen, but the system becomes more complete as our blindness is divided into smaller pieces. That is one of the quiet miracles of instrumentation. Not miracle as magic, miracle as achievement. A species with eyes tuned for daylight learned to detect a cluster atmosphere, glowing in radiation our bodies cannot sense. It learned to map cold gas in a galaxy billions of light years away. It learned to infer energy deposited by jets into plasma spread between galaxies. It learned to speak carefully about a black hole it cannot weigh by direct local orbits. Phoenix is not only a story about an extreme object, it is also a story about the discipline required to know an extreme object without touching it, seeing it plainly, or simplifying it into a myth. The discipline is what keeps the awe clean. Awe becomes cheap when it asks for belief without limits. Phoenix asks for attention inside limits. The mass may be extraordinary, but the estimate is difficult. The black hole may be central, but it does not explain every feature alone. The star formation may be unusual, but it does not mean the black hole is creating stars in a direct or intentional way. The cluster may be extreme, but it still obeys known physics. Each limit removes exaggeration and leaves something stronger behind. What remains is a system where ordinary laws have been given extraordinary scale. Gravity gathers a cluster, plasma glows in X-rays, accretion releases energy, jets push gas, gas cools, stars form, light travels, instruments receive, models interpret. None of those verbs are exotic. The result is. Phoenix shows that the universe does not need new rules to produce almost unimaginable arrangements. It needs enough time, enough mass, and the right environment. That recognition gives the final message its calm force. We began with a number that seemed impossible to hold. 100 billion suns. The number still matters, but it no longer stands alone. It now carries an environment with it. When the listener hears it, they should also feel the central galaxy, the cluster gas, the feedback tension, the star formation, the distance, the measurement caution, and the growth history. The number has become loaded with structure. That is the difference between spectacle and understanding. Spectacle says, look how big. Understanding says, look what that bigness changes. In Phoenix, it changes how we think about a black hole's place in a galaxy. It changes how we think about the relationship between central engines and cluster gas. It changes how we think about star formation in massive central galaxies. It changes how we think about the upper limit of black hole growth. It changes how we think about seeing, because the object itself is not what our eyes can receive. It changes how we think about scale, because the most important size is not always the one drawn on a ruler. The ruler fails first. The system speaks after. That is the true path of the video. The title gives a ruler-breaking claim. The narration replaces the broken ruler with better tools. Mass, energy, time, environment, feedback, cooling, evidence. By the end, larger than a galaxy should feel less like a literal measurement and more like a revelation about compression and consequence. The black hole may be smaller in physical extent than the galaxy around it, yet heavier than many galaxies and powerful enough to help shape a cluster core. That is the refined awe. Refined awe lasts longer than shock. Shock depends on the first hit. Awe with structure keeps working after the video ends. A viewer may forget an exact number, but remember that Phoenix A star is not just a giant. It is a hidden central engine inferred through the behavior of an enormous environment. They may forget the term feedback, but remember matter inward and energy outward. They may forget which telescope sees which gas, but remember that human sight alone would miss almost everything important. They may forget the technical uncertainty, but remember that honest caution made the object feel more real. That is enough. The ending should not try to make them remember everything. It should leave one strong arrangement in the mind. A distant cluster, a central galaxy, hot gas glowing beyond human sight, cavities where energy has pushed matter aside, cold gas where cooling has survived, new stars where gravity has found dense fuel. At the centre, a possible ultramassive black hole, counted not merely by its darkness, but by the order of consequences around it. That arrangement is specific to Phoenix. It cannot be pasted onto any black hole. It belongs to this title because the title's first promise has been corrected, deepened, and paid off. The black hole is not larger than a galaxy as a cartoon object. It is larger in the more difficult sense, as compressed mass, as ancient growth, as feedback source, as required explanation. So the final line should not close the mystery too tightly. It should leave the viewer with a clean, lingering recognition. The most massive thing in the story is hidden, but the hiding is not silence. Outside the horizon, the cluster has been writing all along. And what it writes is not a final answer, but a map of pressure. A map of where energy went, where gas moved, where cooling survived, where stars appeared, where the central engine pushed back against the same material that may one day feed it again. Phoenix is powerful because its evidence does not point in one flat direction. It folds. Matter goes inward, energy goes outward. Gas cools, feedback heats. The central object hides, the surrounding system reveals. That folding is the shape of the subject. A weaker ending would smooth that shape away. It would say the black hole is unimaginably massive and leave the listener with a single emotion. But Phoenix is not a single emotion object. It carries disbelief in the mass, caution in the measurement, tension in the gas, surprise in the star formation, patience in the timescale, and quiet confidence in the evidence. Each feeling belongs to a different part of the system. Together, they make the final image stable enough to last. The black hole's possible mass still sits at the center of that image. 100 billion suns is not a number the mind can truly hold, but it can hold the consequences. The sun becomes one unit. The Milky Way's central black hole becomes a smaller comparison. Some galaxies become lighter than the object that may sit behind Phoenix's central boundary. The event horizon becomes enormous by black hole standards. The growth history becomes demanding. The cluster environment becomes necessary. The number earns its place only because the story around it has become physical. That is the final protection against exaggeration. If someone says Phoenix A star is larger than a galaxy, the careful answer is, not in the simple way you may imagine. Not as a visible sphere wider than a galactic disk, not as a black wall stretched across stars, but possibly larger than many galaxies in mass, possibly grown inside one of the richest environments for central accumulation, possibly powerful enough, through its active surroundings, to help shape the thermal state of gas across a cluster core. The corrected version is less cartoonish and more astonishing. Correction is not deflation, it is refinement. The title begins a spectacle. The evidence turns it into architecture. We do not lose the awe by removing the wrong picture, we gain a better one. Instead of a galaxy-sized hole, we see a central galaxy inside a cluster. Instead of a monster, we see a feedback engine. Instead of vague darkness, we see a boundary surrounded by measurable activity. Instead of a number floating alone, we see gas, cavities, cooling, stars, and time arranged around a hidden mass. That arrangement is what the viewer should keep. A hot atmosphere spread between galaxies, cavities carved by outflows, colder material surviving near the core, star formation continuing where feedback has not fully won, a central galaxy built by long assembly, an ultramassive black hole candidate whose exact mass is difficult, but whose role cannot be ignored. No piece is ornamental, each one strengthens the next. The hot gas matters because it makes feedback visible. The cavities matter because they show energy has moved outward. The cold gas matters because it shows cooling has reached beyond theory. The stars matter because they prove the cooling has crossed into consequence. The black hole matters because the system keeps bending back toward it. That is the tight structure beneath the calm surface of the narration. It should feel effortless to hear, but the logic underneath must be firm. The listener should never feel lectured. They should feel carried from one necessary idea to the next, with no wasted detours and no repeated emotional beat. Every return to scale must sharpen. Every return to the black hole must change its role. Every return to the cluster must reveal why the center matters more. By this stage, Phoenix A star is no longer only the thing being described. It is the tool that changes how the whole environment is read. Without it, the central activity loses its engine. Without the activity, the cavities lose their cause. Without the cavities, the feedback story loses its record. Without cooling, the star formation has no fuel path. Without star formation, Phoenix becomes less exceptional. Without the cluster, the black hole's extreme growth becomes harder to place. The system is a chain. Pull one link away, and the shape changes. That dependency is the final form of scale. The largest thing is not always the object that fills the most space. Sometimes the largest thing is the one that reorganizes the explanation. Phoenix A star is large in that sense. It sits at the place where many lines of evidence converge: mass, growth, feedback, cooling, star formation, and distance. It is not the only actor in the cluster, but it is one of the reasons the cluster core becomes a story instead of a collection of unrelated observations. This is why the ending should avoid triumph. No one has conquered Phoenix. No one has made its horizon transparent. No one has pinned down every phase of its history. Future observations may refine the mass, improve the models, and trace the gas in greater detail. The best ending is not victory over mystery. It is respect for a system that has become partly readable without becoming simple. Partly readable is already extraordinary. A species on one planet orbiting one ordinary star can infer the presence and possible mass of a black hole billions of light years away. It can map hot gas between galaxies. It can detect cold material in a distant cluster core. It can connect cavities to outflows, outflows to accretion, accretion to a hidden boundary, and that boundary to a mass so large that the Sun becomes a small token on an impossible scale. This is not a sentimental point. It is a factual one. Understanding itself has reach. But the reach is disciplined. It stops where evidence stops. It says candidate where candidate is the right word. It says estimate where the measurement is indirect. It says may where the system is not yet fully pinned down. Those words are not weakness. They are what keep the script worthy of trust. Phoenix does not need false certainty. Its real uncertainties are more interesting than a fake conclusion. The final movement can now become almost still. Imagine the cluster not as a dramatic explosion, but as a vast arrangement holding traces of long action. The central galaxy sits in the core. Around it, hot gas glows in a language human eyes cannot read. Within that gas, cavities mark where energy has done work. Colder material gathers where cooling has not been stopped. Stars form from that material, slowly by human standards, rapidly for such a massive central galaxy. At the centre, unseen, lies the black hole candidate that made the first number feel impossible. Nothing needs to move quickly in this image. The power is in the fact that it has moved at all. Energy has crossed from the central engine into the cluster atmosphere. Gas has crossed from hotter states toward colder ones. Matter has crossed from diffuse reservoirs into stars. Light has crossed billions of years to reach Earth. Human understanding has crossed from a headline to a structure. Each crossing is different. Each one adds to the final weight. Only the event horizon allows no crossing back. That boundary remains the hard centre of the story. It is where communication ends, where the black hole keeps its deepest privacy. But outside it, nothing is silent. Outside it, the universe has left enough marks for the hidden centre to become part of knowledge. That contrast is the final clean line. The inside is closed, the surroundings are readable. Phoenix A star is therefore not remembered as a hole that replaces a galaxy. It is remembered as a possible galaxy mass centre inside a galaxy cluster, known through the behaviour of what remains outside its reach. Its darkness is not the whole story. Its influence is. Its mass is not the whole story. Its history is. Its size is not the whole story. Its consequences are. And when the title says 100 billion suns, the final answer should not be just awe at the number. It should be the recognition that a number that large only becomes meaningful when the universe around it begins to answer. And the answer has been coming from the beginning, only changing form as the scale became clearer. First, it answered through the Sun, by making the Sun too small to remain useful. Then it answered through the Milky Way's centre, by making even Sagittarius A star feel like a local reference rather than an upper limit. Then it answered through galaxies, by showing that mass and width are not the same kind of greatness. Then it answered through the Phoenix cluster, where the black hole's meaning could no longer be separated from gas, feedback, cooling, and stars. That is the completed movement, number into system. The number alone would have been easy to forget. 100 billion suns sounds enormous, but the mind cannot live inside it for long. It needs consequence. Phoenix gives consequence in layers. A central galaxy that has grown through deep time. A possible ultramassive black hole at its core. Hot plasma spread between galaxies. Cavities where energy has moved outward. Cold material where cooling has survived. Star formation where a simpler feedback story would expect quieter gas. Light from all of it arriving late, carrying an old state of a still changing system. Nothing in that image is decorative. The hot gas is the medium, the cavities are the record. The cold gas is the bridge. The stars are the outcome. The black hole is the hidden centre that makes the sequence harder, stranger, and more important. If any one of those pieces is removed, Phoenix becomes flatter. With all of them present, the title finally stops being a claim about a giant thing and becomes a story about an extreme relationship. That relationship is the real scale. The event horizon marks the place where the outside universe loses contact. But the story we can read begins just outside that loss, where matter still has time to shine, heat, orbit, and release energy. From there, the influence travels outward, not as magic, not as hunger, but as physics. Accretion powers activity. Activity drives outflows. Outflows disturb gas. Disturbed gas changes its thermal path. Cooling survives in some places. Stars form from the cooled material. The central black hole grows inside the same environment it helps regulate. There is no need to make that sound more dramatic than it is. The drama is already in the chain. It is in the fact that a black hole can be both final and not final, depending on where you look. Final at the horizon, not final in the surrounding system. Final for matter that crosses inward, not final for the energy released before the crossing. Final as an interior boundary, not final as a source of consequences. Phoenix A star forces those distinctions to stay alive at the same time. That is why the old image of a black hole as a simple devourer has to be left behind. It is too small. It gives the black hole one action and one mood. Phoenix shows a better picture, a central object that removes some matter from the observable universe while helping shape the conditions of matter that remains outside. It does not choose. It does not create with intention. It does not destroy with malice. It participates through gravity, accretion, energy release, and feedback. That is colder than myth, and more powerful. The final humility is not that we are small. We are small, but that is not the most interesting truth here. The more interesting truth is that small observers can learn to read systems too large to experience directly. We cannot touch the Phoenix cluster. We cannot watch its gas evolve across millions of years. We cannot cross the distance separating us from that ancient light. We cannot see inside the event horizon. Still, we can follow the evidence to the edge. We can separate mass from diameter, candidate from certainty, influence from spectacle. We can let the system be extreme without making it false. That is a rare kind of reach. It does not conquer the object. It does not remove the mystery. It does not turn Phoenix A star into something familiar. It does something better. It makes the unfamiliar coherent. It shows why the black hole may be so massive, why the estimate is difficult, why the cluster matters, why the gas matters, why star formation matters, and why the title only becomes true in the deepest sense after the simple picture has been corrected. Corrected, not weakened. The black hole is not a galaxy-sized sphere. It is more unsettling than that. It may be a galaxy mass concentration inside the core of a galaxy cluster, hidden behind a horizon and surrounded by a system that keeps revealing its effects. It may be one of the most extreme black holes ever proposed, but its importance does not depend only on being first in a ranking. Its importance is that Phoenix makes the upper edge of black hole growth visible through the behavior of an entire environment. That is what remains after the headline burns away. A system of traces. Hot gas carrying the memory of energy. Cavities shaped by outflows. Colder material marking the survival of cooling. Stars proving that some gas crossed into dense fuel. A central galaxy showing the long accumulation of a cluster core. A black hole candidate whose possible mass is almost beyond ordinary comparison. Ancient light carrying the whole arrangement toward a planet where it can be decoded. The decoding is unfinished, and that is right. Future observations may revise the mass. They may clarify how the gas cools. They may show more detail in the relationship between jets, cavities, and star formation. They may strengthen or soften the claim that Phoenix A star sits near the 100 billion solar mass scale. But revision would not destroy the story. It would continue it. Phoenix is not valuable because it gives a final trophy. It is valuable because it exposes the machinery at the edge: growth, feedback, cooling, uncertainty, and evidence, all in one place. So the final image should stay with the machinery, not the trophy. Imagine the Phoenix cluster as it was when its light began the journey to us. At its heart, a giant central galaxy. Around that galaxy, a hot atmosphere glowing where human sight would see almost nothing. In that atmosphere, cavities pressed by energy from the central engine. Near the core, colder gas gathered along paths that feedback did not erase. From that gas, new stars forming inside a galaxy that should have been quieter. And at the centre, unseen, a possible ultramassive black hole, whose weight may be counted in 100 billion suns. No roar, no monster, no cosmic mouth. Only a hidden centre and the evidence arranged around it. That is enough. Because the deepest power in Phoenix A star is not that it gives us a bigger darkness, it is that it teaches a better way to see. Not with the eye alone, not with fear, not with a ruler held against a galaxy, but with consequence: what moved, what heated, what cooled, what formed, what could not be explained without the central weight. The black hole gives back no light from within its horizon. But outside that boundary, the cluster has written around it for billions of years. And across that writing, in gas and stars and ancient light, the largest thing in the story becomes readable without ever becoming visible.